Hello, everyone. To start off this unit on humans and the environment, we're going to start talking about human population. So, by the end of this very first lesson, you will be able to show human population growth as a line graph. You'll be able to interpret human population growth from a line graph. You'll also be able to calculate population growth rates, predict population growth rates, which includes birth rates and death rates, based on societal factors associated with demographic transition, and compare and contrast the three projections for global future populations by the year 2100.
So, a population is a group of individuals of the same species that live in the same geographic area. So all populations need four things. They all need food, water, and shelter, which are the requirements for the individuals in the population. And then a population also needs space. Population size is the number of individuals in a population. This is influenced by four things: births, which positively affect or cause population growth, deaths, which negatively affect the population or cause a population decline. Immigration with an I means that individuals are coming into the population. So I is for in, and that's positively affecting or causing population growth. And emigration with an E for exiting, so individuals are exiting the population when they emigrate. So it's a negative effect on the population.
All right, now we're going to talk about graphing our population size. And so we're talking about a change over time. So with any change over time, we're going to use a line graph. And we have to remember that time always goes on the x-axis for graphs. So the first thing we do is we plot our data, plot the population size according to the number of individuals at a given time. So let's say in 1950 we had a population of 100, and then in 1960, 200, 1970 the population maybe jumps up to 400, 1980 it jumps up to 800, and so on and so forth until we get a nice little curve, and then we're going to connect all of our dots. All right. Okay, so in our graph, now we can analyze it. So we can see here that our population is growing. And we can tell that because the population is increasing over time, and we have a positive slope to the line. And then over here we have a declining population, where the slope of the line is negative. And then over here, where our slope of the line kind of evens out, it kind of goes back and forth, but it kind of evens out around this area. This is a stable population. All right, so when we're talking about population, one really frequently used calculation is population growth. So we need to know how fast or how slow a population is growing or shrinking in some cases. Okay, so to do that, we have all of our births and immigrations, so that's everything coming into the population. So all of the births plus the immigrations, minus all of the things leaving the population. So that would be the deaths and the emigrations, divided by our total starting population. And since we have a rate, we want this to be in a percentage, so then we need to times by 100. This will give us the next decimal, and then we times it by 100, it'll give us a percent. All right, so again, that's births and immigrations together, minus deaths and emigrations together, divided by the total starting population times 100 to convert it into a percent. So, for example, if we have a city of 10,000 people, and then in that city they have 100 births, 10 deaths, 10 immigrants, and 10 emigrants, what would be their population growth? So, we can just take this information and plug it into our handy-dandy equation that we have here. So we need births first. So we would have 100 births plus our immigrants, so that would be 10 immigrants. And then we would subtract all of the things leaving the population. So that would be our deaths, which is 20 deaths, and immigrants, so that's 10 immigrants. And then we divide that by our total starting population, which was 10,000. And then we multiply by 100. So, and that equals our population growth rate for this city. All right, so then let's do some math. So we have 100 plus 10, which gives us 110, minus 20 plus 10, which gives us 30, divided by 10,000 still, times 100. That still equals our population growth rate. All right, so 110 minus 30 gives us 80 over 10,000 times 100. So then when we divide 80 by 10,000, it's the same as 8 thousandths. So that would be tenths, hundredths, thousandths, times 100. Okay, so then we multiply by 100. So then that effectively moves our decimal places to that way. So since we multiplied by 100, that's going to be a percent. So that is our population, oops, I can't write anymore, our population growth rate for this city. All right, so we'll do a couple more of these in class, and we'll also practice graphing in class.